Professor in Cybersecurity and Policy at the Fletcher School and the School of Engineering, Department of Computer Science at Tufts University. I hope I got that right, Susan.
Absolutely.
Great. Susan Landau has worked at the intersection of cybersecurity, national security law, and policy, and she's written 4 books, including, the name is People Count, Contact Tracing Apps and Public Health, and also Listening In, Cybersecurity in an Insecure Age, which came about because of her congressional testimony in the Apple FBI case, which Mike also mentioned. Landau has frequently briefed US and European policymakers on encryption, surveillance, and cybersecurity issues. And she's been a Senior Staff Privacy Analyst at Google, a distinguished engineer at Sun Microsystems, and a faculty member at Worcester Polytechnic Institute, the University of Massachusetts, Amherst, and Wesleyan University. Susan is currently a member of the National Academies Forum on Cyber Resilience and has served on the National Academies Computer Science and Telecommunications Board, the NSF Computer and Information Science Advisory Committee, and the Information Security and Privacy Advisory Board. Not enough with that, she's also a member of the Cybersecurity Hall of Fame and the Information Systems Security Hall of Fame. And she is a fellow of the AAAS and ACM, and you'll tell us what those acronyms stand for, because I don't know, as well as having been a Guggenheim and Radcliffe Fellow. In the preface to her 2017 book, Listening In, Cybersecurity in an Insecure Age, Susan Landau writes, quote, "The encryption debate, a subject that previously occupied only techies and policy wonks, has now become critically important. How do we secure ourselves in the face of the digital revolution in which our world is increasingly being controlled through bits? This revolution has brought humanity tremendous economic, technological, scientific, and cultural benefits. But it also provides bad actors with the ability to steal and disrupt at a distance, performing serious mischief at scale," unquote. It is our hope that with the breathtaking insight and experience that she brings with her, Professor Landau can help us think together on this roundtable about how to address this revolution in Cryptic Commons, where community needs are incorporated and understood, and insights from mathematics, engineering, cryptography, and the humanities come together to find meaningful solutions. Thank you so much, Susan, for joining us today. And thanks to everybody else for joining us in the roundtable.
Thank you. I'm not sure I've ever had quite such a strong introduction, and now I just hope I can fulfill part of the promise.
I'm sure you will. All right then, Mike.
Well, I don't know how much of the conversation, Susan, you've been participating in, listening to. I know you've been here all day today. I don't know if you were here yesterday.
I caught a little bit of yesterday, and I caught Ross's talk yesterday this morning.
Right. Okay. Well, if my thoughts about the roundtable are that we ought to do 2 things. But one is to get the AHOS team, Raphael and Mads and Astrid and Adrienne, to tell us a little bit about how they see the project's accomplishments, what's been done over the past 3 years, both in terms of substance, but even more in terms of creating an interdisciplinary community and how they think about that and how to move forward. And then to have our various keynote speakers, and Susan, I'll include you in that category, think about where to go from here, what suggestions there might be, what further projects there might be, and how you think about that. But if you have any first thoughts about it, Susan, I'd offer you the floor first, and then come back to Raphael and the others.
So as I was listening today and hearing issues about the differences in vocabulary, I was struck with the kinds of challenges I've met. So for those of you who don't know, I started off as a theoretical computer scientist. I used to prove theorems, very mathematical theorems about algebra, fast algorithms for algebraic problems. And then I moved into doing policy work. And for a while, I wrote policy papers for the scientists, and then I realized those weren't the right people to influence. I should influence the policy people and write law review articles, which I learned how to do. One of the things that struck me as I brief European policymakers and American policymakers is that although we use the same vocabulary, we talk about communications in the IP world, we talk about communications in the telephony world, the underlying technologies are really different. And the lawmakers try to impose the same type of laws on the new technologies as on the previous ones, but they don't make sense. And I'll give you a very quick example to show the problem. Phones move. Most of you use phones that move these days. And wiretapping is slightly more complicated when you have phones that move, but it's not impossible. But what you've got with the new communications world that we live in is that many of our real-time communications are not through the telephone network. They're through some medium like what we're using right now, an application through through the IP communication network. And that means that the service provider, Verizon, BT, what have you, is separated from the provider of, that is the communication service provider is not the same as the application provider. And that makes wiretapping much, much more difficult. And I can draw you a diagram, but I'm not going to take the time right now to show you why. But there I was talking to people in Congress where there was an intent to implement a wiretap, to put forth a wiretap bill in September, I want to say 2006, before an election. And the senator saw a diagram we had drawn about where do you put the wiretap order? Do you put it on the service provider? They don't know where the user is. Do you put it on the application provider? And all of a sudden, the diagram is what explained to the congressperson why this law was not going to work, why the analogies didn't happen. And so when we talk about vocabulary, we're also talking about a gap of knowledge that I don't really know how to fix at scale. I know how to fix it in small ways. You're teaching your course, Michael, with Hal and Danny. I'm running a master's program in cybersecurity and public policy at Tufts. But in the large, I don't know how to fix it. It's too easy for us. It's something we do all the time as human beings. We take analogies from a world we know and apply them to a world we don't know and think that everything is the same, but it's not. And so that's a, understanding the analogies and showing why they break, I think, is an important research question. And that's what I'll take from right now, start with.
Great. So that, in fact, as I understand it, is one of the places that the Secure Project began or was thinking about. So, Raphael, do you want to sort of begin the discussion?
Sure, I would love to. And your question was very concrete in the sense that what are the results, and I won't talk about those technical results, right? Protocol here adding some small epsilon or free epsilon in some other places. Maybe that's not that vital. But I think more as a process of developing, and if I may, we had those type of conversation in these two or rather three camps where I was the naive, idealistic part, and then more realistic. That was more Adrian and Astrid, and somehow in the middle was a mess. So you will hear from them, but I have some excuses of my kind of life and training. I started as an engineer doing PhD in engineering, and I was deeply tired of waving hands. So I did my second PhD in mathematics to be very formal. So maybe that is that I love formal language. And I think I pressed a bit. I have this ambition when we started the language to formalize a bit anthropology even. And then when I heard what Helen was doing with formal logics, oh, my heart, it was like beautiful. I need also conditional probability, then I would be very, very happy man. And actually, it would be actually nice to look at, Helen, at your work and put some more uncertainty in this. But I realized one thing, that nothing happens without the social needs and everything which is around us. It's not only a process of my self-seeking here. The social influence, it's on pure research on so idealistic object is much bigger than I would ever dream. So I developed myself in this perspective. One small comment before I will give the word to others in the team is that somehow maybe only in Professor Ross's lecture there was this, that actually those who break the codes, they are also positive people in some sense. In all our pictures, the people who are hackers, they are badly, their clothes are not untidy, their hair the same. But by the way, Turing was very well dressed gentleman who also broke the code. And by this, I will say that some people were heroes during the Second World War of doing this, and we make them into bad people. Breaking the codes or breaking the secrets, it's also a way of making our world more transparent. So it's not that easy question that we should hide everything. This is one observation. And the second, and I will shut up, is the thing like technology. We had aeroplanes. The first aeroplanes were actually very unsecure, or rather unsafe, if we should really use the better words. But in time, actually, it's a very safe means of transport. And there is always probability of a disaster. The matter is how big. Full stop. Thank you.
Mads?
Yeah, I was just sitting here thinking of something clever to say. I can maybe explain a bit about as an example, some of the work we've done here, or I should say, it was rather done by Jane. So going back to some of the stuff I mentioned yesterday, we were asking the questions. If we have a bunch of devices that are connected in a wireless network, can these then collaborate and solve problems, engineering problems, without revealing the private information held by these individual devices? And we actually came up with some really nice results there that show that this can be done. And we suggest the algorithms for solving quite general complex optimization problems, which means you can take this and you can use it for solving all kinds of different problems in control and automation and signal processing and machine learning and so forth. And but it's based on a very specific way of looking at information. And it's rooted in information theory, which of course goes back to the mid-40s. Sorry about the noise. There's 3 dogs here at the moment, 2 kids. Yeah. And information theory is useful for a lot of things and good for understanding and analyzing a lot of problems, but it's also not a perfect measure of information. And just a very simple example of that is that the white noise has a flat spectrum or IID, identically independent distributed variables there, have the maximum information from the point of view of information theory, but it has no information from a perceptual point of view. There are probably some that will argue it has still so much information that we can't handle it or something like that. But the point here is that we were trying to optimize our algorithms and try to come up with sort of an operational approach to solving engineering problems. And we would say, well, we can measure if we pretend we're listening in on what's going on in the network here and what's going on, the secret information held by the individual devices, and we measure the mutual information, and we can show that that starts with being nothing and then it converges slowly to the result of the optimization that the devices have agreed to solve together. And that's really nice. But then I started wondering, what about other kinds of information that you can't quantify this way? And then I get really nervous also listening in on all the talks yesterday and today, and feel kind of naive because in doing this, we're doing kind of like what Rafael was talking about earlier here, that we're just sort of thinking we can solve all the problems as we go along and all that, but we may be looking completely wrong at the problem there. And I think the reason I bring this up is that, can we trust the people who make products and make their living off selling ads and stuff like that with our information, and that they're going to be transparent about what they do and all that? And then I'm thinking, well, then we need to be able to measure it somehow, but we don't have really good measures of information. So it actually comes down to really fundamental mathematical questions, right? And Andreas's talk earlier, where he was talking about speech-related things, it's a very good way of saying it, right? If you want to do speech recognition, you want to be able to recognize the words, but not who's saying it, right? And in speaker recognition, it's the other way around, right? So how do I test my Sonos device that's sitting in my bedroom that it's not listening in on things that it's not supposed to? I know that a lot of these companies feel very take their responsibilities very seriously. Like Sonos, for example, have been in legal battles with Google over the front end to some of their devices and who could have the data and stuff like that for this reason there. But yeah, these are some of the things I wonder about. And again, I think it boils down to very sort of simple mathematical questions there. And if we don't manage to come up with operational and mathematically tractable measures of information and privacy, these sorts of things, it's going to be very hard to actually design algorithms that live up to the expectations we have. Yeah.
Great. So I just want to underscore your last word, and that's expectations. And a word that Ross in his keynote had in the title, but he never actually talked about, which is utopia or utopian visions. I don't know if that's a segue, Astrid and Adrian, but we'll leave it now to the two of you.
Thanks, Mike. I'm not sure I want to be held responsible for utopia. Certainly not. But I was scribbling a bit, listening and trying to think about, where can we add into this mix. I mean, it was a really challenging and a really wonderful opportunity to grow as researchers in this project. I mean, we were met with things that in our world seemed really, really exotic. Sitting and talking together with mathematicians about how the world works was just really, yeah. We felt like at one point I likened it to doing fieldwork on, with those sort of traditional old-fashioned anthropology fieldwork someplace where you don't understand the language or the rituals or the social relationships, the kinship charts. You had no idea.
You were observing the natives.
Well, we also became part of them, I have to say. So, so I guess we were interested in first, not just trying to understand, as Nina calls them, the deficient users, but also trying to understand the social lives and logics and indeed aesthetics among our colleagues, because how could we help build something if we didn't understand what they were doing, at least to some extent. So the beginning of the project was really about how do we, with our social lens, how do we step into the lab with our mathematicians, engineering, and cryptographer colleagues, and try and understand what their logics were. What were they going for? And there was frustration, of course. And first of all, from their side, there was a frustration that they were perhaps trying to codify something that in some ways could be formalized. I remember having long conversations with MES about privacy, for example. But on the other hand, not really knowing what it means in practice in the actual world. How do we define this? Do we know what we're doing in actual applied situations? And that led us to an interesting, and this was kind of across the board in all three work packages, an interesting identification of the tension between the ideal and the real. So the utopian that you talk about, Mike, and then the real, as I understand it, in any case, as a kind of a model to test, as a test to see, does this correspond to the ideal, or is it differentiate from it? And the third part of this was then our insistence on the actual. And of course, it was an insistence on the actual in theory, because we never found use cases in the project. And that's another discussion that we can have as to why. But it was interesting that we wanted to find the actual, but there were also issues about what we're calling the actual in some of the technical work as well. And Mass was referencing Changshu or Jane's work in terms of graph topology, and realizing that the MPC model was an ideal, but it didn't in any way correspond to how actual communication was going on, for example, in the internet. And we had similar questions about with Katrine, Raphael's PhD student, about real numbers and integers and MPC, and how those could function, how real numbers could be useful, or could we even use them? Would it work in that model if we were interested in real numbers? And I'm sure you'll all correct me, because I'm saying it all wrong, but I'm trying to represent it as best as I can. And then I think there was also there was an insistence, there was another frustration on the other side, and that was from our colleagues, frustration with our insistence to try and see the social in terms that you had formalized definitions for. And this is this was the comment that we heard before, Susan, that you mentioned about analogies, right? We were hearing stories about trust. And we said, oh, we know something about trust. We as anthropologists, we can say something about that. And then realizing that that's not what our colleagues mean by it. It means something else. And how is there, in your words, Helen, is there a bridge there? Can we bridge that gap? Hence the title of the whole workshop. And how do we do that? Mm-hmm. And I think then the last thing I'll say, because I'm chattering away and it'll be Astrid's turn. We became interested in scale. And that's kind of towards the end here, because a lot of the problems that Ross so accurately, painfully detailed, presented to us yesterday. And I mean, I left feeling educated and disturbed by the run through that he gave us, was that part of if we want to scale privacy and security, it's because we have a problem that exists at scale. And so I wonder whether it is possible to do some kind of intervention that doesn't scale, but is very specific and is very actual and focuses on very, very specific communities, specific needs, the co-creation that Mike was talking about again with Nina. Can we build small dots that can slowly grow as we move forward, rather than starting from great scale on the top? So I'll stop talking now. Astrid, go ahead.
Thanks, Adrian.
Yeah.
I think I just want to add one aspect of trust, and in terms of sort of building an interdisciplinary team. And I think in a way it's a shame that such relations are confined by the temporality and the endurance of a project, right? And hopefully we will be able to work together, but it takes a lot of time actually to build relations of trust among your co-researchers, especially when you don't have a common ground or a common language to gather in or around. And that's an issue of trust as well, but in a different dimension. And you have this, there's an STS scholar called Helen Varan, who talks a lot or works a lot about working across epistemic differences, and talks about you have to work in good faith, because you can't always prove the relations and the epistemic sort of standard points of the other researchers. You can't prove that they're right, but you need to build relations of trust and then somehow collaborate in good faith. Yeah, thanks. With curiosity is very important too.
Yeah.
So just to push, not to be answered at the moment, but just to push on the question of building trust within a community and extending it over time. My own experience is that indeed those things take time, but there's no point in allowing project time. So anthropologists also talk about the dilemmas of project time, particularly in projects that have to do with development work in the third world, that the goals are always being disrupted by project time. And there's no reason in an academic community to allow project time. I know you need to get grants and all of that, but some of my most productive collaborations have been with networks that have been explicitly outside the university and across disciplines, that have some sort of loose problems that they want to solve. And I'm not sure I yet have a clear idea of what the problem sets are that this community wanted to solve and might in the future want to solve. And just one quick vocabulary footnote, I'm not sure that my understanding of utopia, I probably had a totally different idea than what all of you had, has much to do with the ideal. The ideal seems like a much smaller thing than utopia, which has to do with solving larger social problems. And just a reminder, I mean, one of the things that I took away from Ross's history was, as Susan put it in the subtitle to the book Listening In, is that the nature of the insecure world that we live in has itself changed over the last couple of decades. So anyhow, let me turn now to maybe Helen. You haven't said anything yet on this roundtable, and with the thought of both what you've heard from the project team and from whatever you've been able to listen in on, and where you think this conversation should be taken.
Nope, you're muted, Helen.
Yeah, no. Also, I have to apologize. I had mentioned, but I'd forgotten to include Michael, but I mentioned to others that I have to actually leave in about 5 minutes to go to other stuff. But I was busy writing this in the chat, but I think that I'll take my opportunity to say it now that I'm hearing a little bit more about the aims, and it's fabulous because it's really what I've been doing in a lot of my work, which is trying to, and Susan's comment about how do you take these words that look the same but actually cover the concept refers to other things. The up and down the food chain argument, which I'm sorry I didn't get to, says a theory like contextual integrity is it depends on a semantics. The actors are acting in capacities. Physician has meaning. It has linguistic meaning. It has semantics. It has social meaning. Like the norms of contextual integrity are very rich. They're dripping with everything and culture and so forth. Something like consent, what I think partly has been attractive is that it could just be procedural. It's like blah, 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 check this box. And it doesn't matter what the blah, blah, blah says. If you're going to formalize something, it's just click this and everything's fine. We don't need to know what the meaning is. And it feels to me that actually the way people respond to data flow is according to meaning. And one of the biggest issues of mismatch that we're confronting is to look at many of these systems, and I think machine learning can generate, like, there's cause and there's effect, like whatever the sensors and the data primitives, whatever the pattern is, it's like, okay, gets credit, stop the car, or like there's this intermediate stuff that we don't care about anymore if we really subscribe to the machine learning fantasy, if you will. It's just this, there's this stuff, it has no meaning, it's just sensory input, it's a plus minus, it's GPS, you know, latitude, longitude, all numbers, and then you have some kind of output, and the meaning part of it somehow disappears. And the question is, can you even have a theory of privacy for that universe? And my argument is that we have to think a lot. Like, I don't have a quick answer. I know that the consent model is fraught and it's not going to work. We've seen it fail, and yet we live with it. How we do this other thing when we have cause and effect with non-meaningful informational input, I have no idea. And I think this gets a little bit to Mads's kind of frustration. Okay, that's it.
Thank you, Susan.
So I just want to say here that a lot of what we're dealing with is information asymmetries. And in a market, now to pull in economics as if we didn't have enough fields in already. Hold on, my resilient phone is ringing. I have a wire line. I live in a place where we get snow. It's unplugged now. As if we didn't have enough fields to deal with, now bringing in economics, we have information asymmetries. And information asymmetries that in some places we can understand. We understand what the information asymmetries are in China, in Xinjiang province. We get those. But in lots of places, if you think about Google, if you think about Facebook, very few people have any understanding of the information asymmetries. With a lack of understanding of the information asymmetries, you can't get to legislation that makes sense. I sort of skip the philosophical piece that Helen always goes to when I go to the practical piece of how am I going to protect people? But nobody really understands the asymmetries particularly well. And that's an important and complicated piece of it. So I think that's actually a good question for the anthropologists to start looking at.
I have to run. I'm sorry. Thank you, Susan.
Thank you,
I can be practical too.
I know.
Okay.
And I can be philosophical too.
Okay. Thanks, everybody. Bye-bye.
So much, Helen. Thank you so much. Rafael had his hand up, and otherwise I want to say something.
Yes, and then it's a bit of shame that Helen cannot hear it, but I have to disagree. Sorry, with the following, that what is inside it should bother us. And in machine learning, I'm referring to the machine learning example, and I'm not sure whether I agree, because what it is about is there is some information, and I should be able to predict what it will happen in the future. And the models we are building, which we are claiming that they are working properly, they are just approximation of the situation. Taking an example of a classical mechanics, it was all right for Newton. It was okay for Kepler, but as the velocity is growing, or as the size is being smaller, it does not work. And actually, an example of, again, this quantum theory, and again, this theory is purely produced to reproduce the experiment and close the gaps between old theory and the new theory. This is about this is a bit like what we had this discussion, Michael, and you said that that Flack was another person of Polish origin working in this field, and I allow myself to check it. And this is what is you know, too many of those discrepancies generates a new thoughts. But coming to the point that I think we don't need to understand properly what is inside. It's just a model. Thank you.
Can I respond to that?
Yeah.
So I think we've had these debates and conversations over the past 3 years, and they've always been fruitful. And I think that I want to note here, even though we talked about frustration and not being able to understand each other, and Raphael also noted that we have, you know, 3 very different kinds of scientific methods. I think that one of the markers of trust, at least in our little community in the Secure Project, was actually the ability to feel safe. First of all, asking dumb questions. We did that a lot, and we felt safe asking them, and we also felt safe disagreeing. And so even though we disagree with each other, and even though we don't always understand each other, there was an absolutely fabulous atmosphere in our group where we could ask all those dumb questions, and they could ask us dumb questions, and so on. And I think that's really, really fruitful. Mm-hmm. And continuing in that vein of disagreement, I do want to point out, I think Helen brought it up with her question here about consent. And I think one of the things I came away with yesterday was that it's felt like there were 2 layers. There was sort of this layer of different kinds of technical solutions and logics and technologies and so on. And underneath this, there was this layer, I can really only call it pain. There was a layer of pain because some bad stuff is happening. There are people whose privacy is being abused, their information is being used in ways that can hurt them. There are people who are not feeling represented. And that's why I feel like it was important for us to be in this project to try and understand what are the social implications of not having your data secured in whatever way it is that you feel like you need to have it secured. And so to Raphael, I think that, and we've had these conversations before, is that if machine learning is just a model, then we're training the model on the data that we put into it. But the data is, of course, not just neutral data. It's a representation of things that happen in the world. It's a representation of the status quo. And as we've heard, and as we know, the status quo is lots of things, but it's also, for some people, in certain situations, appropriate flow of information is oppressive. So I think it's really important that we understand what is in between those machine learning models. But again, I'm an anthropologist, and there's probably lots about this technically that I'm missing, but you know, the conversation continues. So.
Astrid.
I see that there's some comments in the chat, and both from Shangshu and from Nina. And Mike, whenever there's a room, I think it would be wonderful to include some voices, if it's all right, according to the roundtable. I know it's a roundtable, but still.
No, absolutely.
So I'll pass on the word to whoever, Mike, you.
Well, Nina was first, so Nina.
No, I just wanted to share that because it really reminded me of what Adrian and Astrid just said about how can we work together. And I mean, in STS, we're quite familiar with being the useful idiot, right? But this is also not a role that you want to take all the time, perhaps. So, I mean, personally, I do not mind, but the question of how to translate these different kinds of expertise and knowledge, but not only to translate, but to have this really open and reflexive and productive discussions. And in the book that that I'm editing with Jeffrey Boker and others, there we have this chapter where we tried over 2 years to engage in such an experimental conversation. It was about hacking satellites, but that's just one thing, right? We took this as an example for how to communicate with each other. And then the hacker who was involved in that experiment, for him, I think it was the hardest part was that we were so stupid. So how to explain what he actually does, right? But then when we were asking questions like, okay, but how do you see your work as being political? And he started to struggle. So it took us a long time. But I think in the end of that, we really found a way to not speak about each other, but speak together, which is why in the chapter, we do not identify the speakers' positions, but it's always the four of us speaking as a collective, although we have these different backgrounds and expertise. So that's just, I wanted just to share that because I think it kind of relates to what you discussed for the Secure project. And sorry for the self-advertising.
No, and the book is in the chat, so I look forward to that very much. Just a little pushback because I'm very interested in writing tactics across disciplines and across positions. So I'm not quite sure what it means to write as a community when what is at issue is, like in a play, is the staging of different points of view, different epistemologies, different arguments, different interests, and so on. So I don't know if you can answer that quickly, or I'll just wait for the book and see how you do it.
Very, very quickly, what was for us an important concern is that there are these different valuation logics, right? For us as academics, it's a chapter in a book, but for him, that was not really relevant. So how can we account for these different, like the amount of time that you spend for something that in the end, of course, is a chapter in a book that has a different value for all of us. But what we did is that we had these conversations and then we recorded them and we annotated documents. And in the initial version, we also included the sketches. So we tried to find a way, and that was one of the hardest parts, to divide the work between us without kind of exploiting the expert engineer and just trying to get his knowledge on the technical stuff and then including it in one of our academic publications. So this was kind of part of the experiment that we did. So how can we be fair to all of us while we still, all of us find this interesting?
Susan?
So I've had the experience of writing law review pieces and also of writing technical pieces. And it's exhausting to go between the two. In a technical piece, you submit it to a journal, they either say yes or no. If they say maybe, they say, you have a problem over here, you need to explain this, or your proof has a lacuna, or your proof is wrong, or, and they only accept it when you fixed it, everything. For a law review, which is reviewed by second-year law students, not faculty, they accept it, you sign a contract, and then at some point, out of the blue, you get 100 corrections to do, and you have 10 days to respond. And you do those 100 corrections, or some of them. I'll tell you a story in a minute about not doing one of them. And then sometime later, you get another 100 corrections that are orthogonal to the first set, and you again have 10 days. They're training you to be a lawyer. So here's one that I didn't respond to. We had said something happens so many times a millisecond, and therefore so often a day. And the editor wrote and said, could you explain this? And I said, yes. 1,000 milliseconds in a second, 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day. And if you make me put that in a footnote, I will be mortified. And they dropped it. But the point about it is that a law review piece is really discursive, and a scientific piece is narrow and focused. And after I do a law review piece, I'm really ruined for doing a science piece. I have to think really hard. And so here it is, one person trying to look in two different ways. Now imagine two people with their two different experiences. So it's not just the vocabulary and not just the what will they get out of it, but it's also the whole style of the effort that is so very different. There's much more. Steve Bellevin has a column in which he delineates the differences.
Mads, and then I want to come back to Zhang Xu.
Yeah, I was just going to return to the discussion about the machine learning and why this issue of understanding what the models are and so forth, why this is important. Because I think everybody who's worked on machine learning knows that the models you get are no better than the data you put into these things. And there's just tons and tons and tons of examples of really, really bad biases in the data sets. I'm sure you've all seen a lot of them with, with those, the Google and that have trained their face recognizer on the employees, and just one horrific example after another. And when I think about that and how to avoid it, it's not a theory and algorithm problem. I mean, maybe we like to think it is, but it's not, because it's about how you collect the data and you make sure you collect all the relevant data and all that. And there's no guarantee, right? There's no way of proving that you have all the relevant data, except for somebody trying to come up with counterexamples. And unfortunately, it seems to also be the case with a lot of this security and privacy, right? And if we look at cryptography there, what are you doing there? Well, you're trying to prove conditions under which things are secure and so forth. But it's also quite clear that as soon as we go from the cryptography to the engineering, like the work we've done, we can't prove the things we would like to prove. And maybe it doesn't even make sense, as Andreas's Nauch's examples were showed earlier. Maybe it's so context dependent that we can't hope to prove these things. And now returning to then the comment that maybe Jane is going to make in a second, which was that, is there really a substitute simply for doing the best we can right now? I'm not sure there is. Are we going to stop all the work on machine learning and all the wonderful technology and that's going to enable all sorts of things and solve all kinds of problems because we have some concerns? I don't think that's a viable approach either, right? But for sure we need some pushback. We need somebody to speak up for the people whose privacy is being violated in ways that they don't even realize, and with things they buy from companies like smart speakers they put in their bedroom and so forth. Yeah.
Changshu?
Hi, this is Chung Shou, and I am a PhD student. I'm supervised by math, and I actually math just pretty much represent my comments or so. Yeah, maybe I can just share a few things. Like when I first joined this project, I think it's the same as Andrew and Astrid. I'm super overwhelmed, and there are so many different expert in different fields, and they're talking a lot of things, and I have no idea what they're talking about, and it's been quite challenging throughout the 3 years, but it's super interesting, and it's super interesting, I would like to say, and I've gained a lot throughout these 3 years. Also for the comments about the machine learning, and also we do not have a specific we can never argue that our definition of privacy is correct. Just how dare we to say that, because we do, for example, we do not have a common ground or something. So but I think this is a very fair and good start, that we first to have something, and then we have argument and we discuss, okay, you are wrong or you are right, or you are right in this perspective, or you are wrong in that perspective. So then we can develop more mature or more so this is just some thinking that sometimes we cannot find a solution to a super complex and we don't even understand problem or a big problem. We find one piece and then we try to solve that, even maybe that's not the main problem, or that's even the wrong problem, but at least we have something to start with, and to argue, to discuss, and to put different things inside, and from that we can be more together better understanding, or it's a starting point. And yeah, just like Matt mentioned, we use mutual information to quantify the information leakage and to quantify this privacy, because we think privacy, for now we think it's data privacy, but privacy can be a lot of different things, and it's not only about data, right? So yeah, it's just I can see that we have different fear, and yeah, we should be concerned that what we are doing, and I fully agree, and we should be aware that we should be transparent, and as an engineer, we should make it more transparent to the end users that they are using different technology, and they should be aware that there's different threat and danger or the coming things. Yeah, I fully agree, and I just feel like as an engineer or as a scientist, or even say as scientist, we start from somewhere and then we solve the problem along the way, and then we develop it. Yeah, it's just my some thinking. Yeah, thanks.
Thank
Do
you.
the same thing.
Raphael?
Yeah, we were talking about differences of different disciplines, and I just realized that as a mathematician, as an engineer, as a technical person, we are trained to look positive upon that there exists a solution. It's just in the, and you know how it is also in being among the same type of people, we even more trust by discussing this. And this means that we consider some of the questions people from more from other perspective as maybe a bit nihilistic and aggression almost on our territory. And I will give you an example. When was it? Tuesday, when I couldn't meet you because I said that I had a workshop I organized in engineering perspective, and you know, a person there suddenly said, well, these differential equations like a basic. It's like a basic of all engineering. If differential equation of Leibniz-Newton do not work, we better close the shop. And he's just saying, well, I don't think there is a meaning in this differential equation. I don't think there is a meaning in modeling. And he's right, because there are some assumptions which are never ever satisfied. It's just idealized. It's you know, we look at a car, we look at four wheels, and as an engineer, I have this picture. It's just a circle with exact radius of 0.2 meters or something like this, whatever it is. But I idealize, and that's why it takes so long time before the solution is in the heads of R&D departments or even university, before there is a product, because there is a huge discrepancy. And the solution is by these small changes here and then, ad hoc things which have nothing to do with science. So by this, I just say that there are some idealized objects which we use, also here in the security perspective, which we use as a guideline. It's nothing else, just a guideline.
So I don't think that intelligent social scientists would disagree with any of that. There are a lot of non-intelligent social scientists, I grant you. But I think what Mads and Jane and Raphael just illustrated was another divide, and that's between mathematics and engineering, or between science and engineering. So in social science, we use ideal types as well. I mean, we talk about ideal types, and we talk about modes of a different form of what we call social engineering, which is not manipulating individuals, but trying to reshape society or different parts of society. So we have all of that. I think what I heard, Mads, you may not have intended it quite this way, but there was a radical dichotomy between things that go wrong that you didn't think about in creating something, and proving why it's wrong, or making a better proof or something. Those seem to me precisely the distinction between science or mathematics and engineering on the other side. Engineering proceeds by iteration, right? And so when you said, oh, counterexamples, and you seem to dismiss that as intellectually a less important input, the social scientist would say, well, it may seem like whack-a-mole to the proof standards, but in fact, that's an important input. So I don't think it's either or, but it's in that continuum back and forth continually.
If I may respond to that, I
Yeah,
think
sure.
you're right. But the thing is that both Rafael and I are quite mathematical in our approach. And we like, so we were also telling Adrienne and Astrid that that mathematics is like our philosophy, right? That's the purest form of our knowledge and understanding. And we would prefer if we could start with some basic assumptions and derive some solution, right? And it's the same in cryptography, that in a lot of cases you can prove analytically that something is the case. And it's only when that fails that you will say, okay, I'm going to do the best I can. And then we'll see if somebody comes up with a counterexample. Right? But at the same time, I fully recognize that, you know, even some of the most fantastic mathematical results have come about this way, right? With, you know, Fourier series and transforms and stuff like that. But I think you're right, and it's like, and again, in mathematics, we can't always say what we want to know, right? We make the statements that we can make, but it's not always what we want to know. Yeah.
Susan?
So you reminded me of a story, and it's as I said, I started off as a theoretical computer scientist. I happen to be married to a complexity theorist, so he proves theorems for a living. And one day he came home and I said, I figured out Washington. And he said, yes. And I said, facts are only 10% of the equation. And he looked at me as if I'd lost my mind. And I repeated it. And he continued to look at me as if I'd lost my mind, and I didn't try it anymore because he proves theorems for a living. But when I went down to a meeting in DC about the projects that the intelligence agencies might pursue in related to crypto and security and so on, this was post September 11th, there was a group of civil liberties people working within the government, and then there was a group of cryptographers and security people from outside. The people in Washington who are policy folks, as soon as I said it, grinned and said, exactly right. The computer scientists, one of them was steaming red, mad at me, and said to me, how can you think like that? How can you think like that? Facts are only 10% of the equation when you're doing public policy work.
That's a great line. I'll have to remember that. It also strikes me, Mads, just to go back to your counter intervention, that so my mother was a mathematician, and a geometer. So she starts with definitions and axioms, you know, Euclid and non-Euclidean geometry and all of that sort of stuff. Social scientists begin with problems, not with axioms and not with definitions. One of my professors, whose name for some reason is not always well received, but Karl Popper, one of the philosophers of science, used to always say, you never start with definitions. Definitions come up when a problem comes up with the term that you're using, and you need to make a distinction. That's when definitions are important. So, you know, once again, what we're doing at the moment is we're defining different procedures that different disciplines use. But I think all of us, there's something really interesting. So Popper also had this idea that knowledge could be divided into 3 different worlds, and it's not worth going into that, but it's there's a sense in which, let's see how bad a reaction I get from this suggestion, which is the actual world is the largest of the worlds that we're talking about. The ideal world is probably the smallest, and the real world is in between. So we all live in the actual world, and we all use heuristics of one sort or another. And those heuristics have limitations. And as long as we all recognize that simple set of relationships, there is the possibility of talking back and forth and saying, yeah, I want an engineer when he builds a bridge to make sure that it doesn't fall down, right? So I want an algorithm that is designed to do X, Y, and Z to do that. It makes a difference as to whether or not the algorithm turns out to have imperfections in it, which can be corrected, as opposed to the question of that algorithm is providing benefits for whom, which is the question that Adrienne raised. Astrid, you have your hand up. Oh, I don't know. You probably have the same hand, the two of you.
We're Astrian. I just wanted to just flag the fact that I know that Susan, you need to leave. And
Yes.
if you need to leave, then you leave, and we're just really.
Thank you. I'm sorry, but
No,
with the time switch, I ran into something.
Thank
Yeah.
you
So
so
thank you very much. I've enjoyed the pieces I've gone to, and thank you very much, all of you.
Thanks for being here.
Thanks,
for being
Susan.
with us, Susan. Really appreciate it.
You're just up the street. I've seen you around, but I don't think we've ever actually met.
Right. I'm actually in Amherst for the last.
Oh, okay.
The husband, who's a complexity theorist, is at
Ah.
UMass, but during the academic year, I'm just down the street and hope to
Right.
be again soon.
Good. Okay. See you.
Unmute you. There you go.
Yeah, I think, Mike, your words were really excellent as a closure to the round table. Just like outlining these three, the ideal, the real, and the actual world, and how we are all living in the actual world. I think that's a nice wrap up of the round table. So thank you. And I think we should, on that note, thank, because that was the final intervention of Michael Fisher, and we should actually give him a huge, enormous hand for being along and holding the Cryptic Commons together throughout this whole 2 days of workshop. So before we give the word to Mads for the closing words, I think we should just
Thank you.
So much. Yeah.
On my side, thank you so much for asking me to participate. I've been on a very sharp learning curve the last 3 or 4 days. So thank you very much for all of that.
Thank you so much for your generous involvement in this, Mike.